To another exam walkthrough series from Capacitence. We're going to be doing 2023 October, question number 9 and question number 18. You can try the question out yourself, and for the examiner report and the mark scheme, you can go to the end of the video. So for question number 9, it says a capacitor discharges through a resistor. The time constant of the circuit is 5 seconds. What is the time taken in seconds for the charge on the plates of the capacitor to half? So the discharge equation for charge is equals to Q is equals to Q naught e to the power minus T over RC, where RC is the time constant. So we want to see when the charge becomes half of what it was initially. So initially the charge was Q naught, and we want to see this Q naught become half Q naught. Right, so we go from Q naught to half Q naught. So we want to find the time taken for this to happen. So instead of Q, we can write half Q naught is equals to Q naught E minus T over RC, which is 5 seconds. That's what they've given us in the question. Okay, so I've just, instead of this, which is basically kind of a general charge, you can plug it, you can plug any value here. So you can plug in 75% of charge, 50%. I have plugged in half Q naught. Okay, now what I'm going to do is I'm going to cancel this out. I'm going to get half E minus to the power minus T over 5. And then we're going to do some math. We're going to take ln on both sides. So ln half is equals to ln E minus T over 5 to the power. And then we're going to cancel this out. Ln E is going to cancel out, and then we're going to get ln half is equals to minus T over 5. Now another way we can write half is 2 to the power minus 1. So ln 2 to the power minus 1 is equals to minus T over 5. And then we know the log rules that this minus 1 we can move to the front. So we'll get minus ln 2 is equals to minus T over 5. The minus cancels out. That's what we're trying to do here. And then we can do ln 2 times 5 is equals to T. So it becomes 5 ln 2. Okay, so I hope that's clear. So 5 ln 2 is the answer, and that's going to be D. So I hope this was clear. Okay, just involved a bit of math and using this equation. So make sure you practice your logs if you are a non-math student. For a math student, this should be fine. Okay, now let's move on to question number 18. So question number 18, it says the student used the circuit shown to determine the capacitance of a capacitor. The student connected the switch to X to charge the capacitor. She then connected the switch to Y so that the capacitor discharged through the 150 kilo ohm resistor. The student started a stopwatch when she connected the switch to Y and recorded the voltmeter reading V every 20 seconds as the capacitor discharged. And then they've given us that graph. And for part A, so part A says the capacitor is labeled as 470 microfarads with a tolerance of plus or minus 10%. Evaluate whether the capacitance of the capacitor is within the stated tolerance. So when you do 10% of 470 microfarads, you're going to get 47 microfarads. Now what I'm going to do is I'm going to do 470 microfarad plus 47 microfarad. 470 microfarad minus 47 microfarad. So I'm going to get 517 microfarad and 423 microfarad. So the capacitor I have needs to have a capacitance between this range. That's basically what this statement here means, right? The tolerance of plus or minus 10% means that this capacitor can have a capacitance between this range. This graph, I need to calculate the capacitance of the capacitor. So this is a voltage against time graph, and it's a graph of discharge. So the equation here would be V is equals to V naught E to the power minus T over RC. So the V naught here is the initial charge, and then the R is the resistance of the circuit, the C is the capacitance, and then the value of V and T, they're going to come from the graph. So the value of V naught is 12 volts. The value of V, which comes from the graph, we take a point, it's going to be 8 volts. The value of t, again, comes from the point we selected on the graph. That's going to be 30 seconds. Then R is going to be 150 kilo ohms. We can change that into 150 times 10 to the raised power of 3 ohms. So now I'm going to be solving this voltage discharge equation. I've plugged in all the values, and now we're going to take ln. But before doing that, I'm just going to move the 12 to the other side. So it's going to be 8 over 12 is equals to e to the power minus 30 over 150 times 10 to the raised power of 3 times c. And now we can take ln. And taking ln on both sides, the ln e is going to cancel out. And then this entire thing that was to the power is going to move forward. Okay, by that I mean it moves here. Okay, so it's going to move right over here. Okay, and then we're going to have the equation looking something like this. So now we can solve and get the value of the capacitance. The value of capacitance as 4.93 times 10 to the raised power of minus 4 farads. I'm going to divide this by times 10 to the raised power of minus 6 to convert it into microfarads, and I'm going to get 493 microfarads. Okay, and you can see that 493 microfarads is going to be less than 517 microfarads. So the capacitance of the capacitor is within the stated tolerance. Okay, that's going to be the answer to that. Now let's move on to part B. So it says an ultracapacitor is a high capacity capacitor. One ultracapacitor has a capacitance of 47 farads. The maximum charge this capacitor can store is 56 coulomb. It is suggested that this capacitor can store 1,000 times as much energy as a 470 microfarad capacitor charged to a potential difference of 12 volts. Assess the validity of this suggestion. So, first of all, what I'm going to do is I'm going to calculate the energy that's going to be stored by the ultracapacitor and the 470 microfarad capacitor. So I'm going to calculate the energy for both of them. I'm going to calculate the energy stored by the ultracapacitor, which I've represented with UC, and the energy stored by the 470 microfarad capacitor. We've got three equations we can use to calculate the energy stored. And according to the values they've given us in the question, we can kind of pick which equation to go with here. So for the ultracapacitor, they've given me the charge and the capacitance, so I can use this equation. So I'm just going to plug in the value and get my answer. That's going to give me 33.36 joules. That's the energy stored by the ultracapacitor. And then to calculate the energy stored by the 470 microfarad capacitor, we need an equation which has the potential difference and the capacitance. And that's going to be this equation here. So we can use half and then 470 times 10 to the raised power of minus 6 and 12 square. And that's going to give me 0.03384 joules. And now what I can do is I can compare both values. I can do 33.36 divided by 0.03384. And that's going to give me 986. And what this 986 actually tells us is that the energy stored by the ultracapacitor is 986 times the energy stored by the 470 microfarad capacitor. Okay, and the question tells that it's actually 1,000 times, and we've gotten 986. So we can say that 986 is close to 1,000, so the claim is accurate. Okay, that's going to be the answer to this question. So I hope everything was clear. Now I'm going to show you the marks in my examiner report.